Good afternoon, grade 10. As you can see, in case you didn't get the change of times for today, we are presenting IT instead of physics. Just a heads up. So physics was this morning at 10, just for the change of plans if you forgot. But if you haven't forgot, hello my grade 10s, I've missed you. I hope everyone had a great weekend. And I'm glad that you remembered to join me today this afternoon. So if you haven't been with us before, welcome to grade 10 IT. So let's look at what we're going to be doing today. So like I mentioned in our last lesson on Friday, we are going to start some theory. So I know that's not everyone's cup of tea, and I'm going to try my best to try make it as interesting as I can. But essentially, what do I want to do today? I just want to spend some time just recapping what we should already know. So I'm not going to spend too much time on every little concept. What I am going to be doing today is I'm just going to take the whole chapter of basic concepts of computing, and I just want to focus on 3 areas. I'm just going to make sure that you understand what the general model of a computer is. I also just want to define what hardware and software is, look at the different types, and then what the different types of computers are. The reason I want to do this is because the next few chapters rely on some existing knowledge. So I thought, let's quickly do a recap. Let's just waken those theory brain cells that we may not have had in the last few while, and let's just get started. So first thing that we want to look at is the basic model of a computer. So a computer is a system. Why? Because it's an arrangement of many parts that work together. Okay? These parts are hardware, so the devices, as well as software, so, sort of like the programs. And all these computer systems follow the same basic model. And essentially, it comes down to something like input, processing, and output. So the fact is that most aspects of modern life work as systems. If you train yourself to understand what is fed into the system, so the input, what processing is done, and what output is delivered in all these systems, you will start to see that the world around us has any possibility. Okay, so this type of model is called the input, processing, and output model. But we get something that looks something like this. So this is an expanded model. So although we normally oversimplify this model in terms of input, processing, and output, there is some sort of idea that we need to remember. We need to also remember that this input, processing, and output cannot exist without some sort of memory and storage. So let's look at how this works. So different hardware devices form the input, the output, the storage, and the communication components. So I just sort of want to look at the devices that form this expanded model of the computer. So if we look at our input devices over here, this allows us to get information or data into the computer. And the most common input devices are keyboards and mouses. Okay, so that's the first thing I want to bring your attention to. The second thing I want to bring your attention to is these output devices. And these allow us to get some sort of feedback from the computer, some sort of output. And the most common output devices that we get are screens, printers, and speakers. Then we get these things called storage devices, and I will look at these a little bit more as we go along, okay? But these allow the computer to keep instructions and data that it is not currently working on, so that it can be accessed and used whenever you need it. And the most common storage devices that we get are something like hard drives, CDs, DVDs, or flash disks. Cool. Then we get something called the process, and this involves our CPU. okay? Our central processing unit. And this is the part of the computer that executes the instructions, okay, or the software. It processes the data, and it manages and controls all the other parts of the computer. So essentially, it's almost like the brain of the computer, okay? And an example of make of CPU. Oh, I'm not sure why I'm muted. Oh, okay, I'm unmuted now. Okay, let's just see the chats. Okay, cool. So, sorry, we're going to carry on. Then we get the CPU, okay? And Intel is one of the major manufacturers of our CPUs. Then we get memory. So memory is the place in the computer where it temporarily stores the set of instructions and data it is currently working on, right? So what is the difference then between storage and memory? Storage we refer to as the information in the data that is permanent, where memory is temporary, okay? And we often refer to RAM, so your random access memory, as memory. Then we get these things called communication devices. And this allows the computers to communicate with each other. So these can include things like routers, modems, and switches, okay? But we'll learn more about these as we go along. So let's check what else we have in store. So this is just something that I need to bring your attention to. These are just small little facts that I thought would be helpful to know. So the first thing that I have is programs have to be loaded. So that just means that when we want to load some sort of program, we transfer it from storage to memory or from memory to storage, okay? Depends on which way we are looking at. But essentially what is happening is 100% we have some sort of program that is stored, but to retrieve information from it, it needs to be in memory because that is what we are working with at the moment, okay? So essentially, the contents of memory only becomes permanent when you save them. So you have to transfer them to storage. If you don't do that, we know that memory is erased when you close the program or when we switch the computer off. So if you haven't saved these contents in memory, you are going to lose them. And that is often what happens, let's say for an example, if we're working in a Word document. We'll be working, and all of a sudden you'll get a notification that it's closed for some or other reason. And all of a sudden you have now lost all the work that you have done. Why? Because all the memory that you were working with had not become permanent before you saved them. Okay, so I just thought that was maybe something important to note. Then we're going to look at data versus information. So this is really, really important. When I'm talking about data, this is raw, unprocessed facts, where information is the result of processing this data, okay? But it has to be meaningful and useful, okay? Let's check. So RAM equals not permanent, volatile, storage. Yes, 100%. So we're going to discuss hard drives and SSD later on. Just a heads up for the people that have also joined us. But essentially, it's exactly that. Memory is not permanent, it's volatile, okay? And storage is permanent and non-volatile, 100%. But let's give an example of this data and information that we actually want to store. So the best example that I always give is if you think of test marks. So for me as a teacher, once I've marked your tests, right? Someone gets 12 out of 20, or someone gets 18 out of 20. Those are raw, unprocessed facts. I have not done anything with that data. They are just random pieces that are going to be combined to form some sort of information. If I have to process that information, let's say for an example, I give out a class average. A class average would be information. I have done something to those marks, okay? I've processed that data to be meaningful and useful. Okay, so those are generally the examples that I give to understand the difference between data and information. So data would be an individual's marks, where maybe information might be a class average. Cool, let's carry on. So now we need to understand that there are these two main parts of a computer that exists, okay? These are called hardware and software, okay? So hardware refers to all the parts of the computer that we can physically touch, okay? I'm talking about the screen, the keyboard, the cables, the components inside your computer, your memory sticks, okay, that type of stuff. But when we're talking about hardware, we also talk about something called a peripheral. So a peripheral is a piece of hardware that exists outside of the box of the computer. So your keyboard and your screen, whereas if you think of the CPU, that's inside of your computer. So that's not a peripheral. Cool. Then we look at something called software. So this just refers to all the programs, okay, what we call the set of instructions that tells the computer what to do. Okay, so that's the difference between hardware and software. Hardware can't work without software, and software can't work without hardware. Perfect. So let's look at some hardware in detail now. Okay, let's spend some time looking at these things. So physical components are input devices, storage, memory, output, communication. Just like we looked at our expanded model of our computer. So let's check here. We are going to look at input devices. So any hardware device that allows you to input data into a computer or interact with the computer. So mostly we would always refer to our mouse or keyboard, but nowadays more popular would be the actual touchscreen keyboard on our smartphones. But this is just something that I need to bring your attention to. When we ask for the actual device, can you see that we physically say the touch screen keyboard? Okay, because essentially, although we are typing on a keyboard on our phone, we don't necessarily refer to it as our keyboard. Okay, if we are working with something that it's touch screen, we always reference the fact that it's touch screen. Okay, but that does not mean that we don't have a keyboard or we don't have a mouse. Cool. So those are input devices. Then we get something called storage devices, like I spoke to you. So this is a hardware device that allows you to store data for later use. There are many different storage devices, okay? Each of these devices have some sort of advantage and some sort of disadvantage. And this is what we're going to look at tomorrow. I'm going to be looking at different types of storage devices and actually checking what is an advantage of an SSD, what would a disadvantage of a HDD be. So let's just discuss the difference between these things over here. So hard disk drives and solid state drives. And this is sometimes the biggest misconception that we find with these storage devices. So I just want to talk about some characteristics that we could compare with these popular storage devices. So if we have to talk about the reliability or the durability of the HDD or the solid state drive, okay? So an SSD has no moving parts. It uses flash memory to store data, which provides better performance and reliability over your hard disk drive, okay? So in case of physical durability, SSDs are considered far more so than your HDDs, okay? So if you think of a hard disk drive, It has moving parts. So it has magnetic patterns, okay? It's susceptible to not only wear and tear over time, but also damage due to movement, okay? But in saying that then, if we think of noise, okay? So, we sometimes hear our fan going when we're working on our computer. That's not necessarily what I'm talking about. With regards to your solid state drives, because there are no physical moving parts, okay, they don't generate any noise necessarily. But if we think of hard disk drives, because they've got little spinning platters, okay, from moving, when it reads and writes, okay, it's almost one of the loudest components within your computer. Okay, then with regards to that, then there's another consequence. We talk about something called heat. So because there's no moving parts with SSDs, so your solid state drives, okay, it's very likely that your computer is not going to overheat. Why? Because no moving parts due to the nature of this flash memory that we talk about. So it just generates less heat, okay? And this helps to increase its lifespan and reliability. But if we think of our hard disk drives, with all these moving parts and all this noise that it generates, these parts come with added heat, which can slowly damage this storage device over time. So because there's greater heat, the greater potential for wear and tear. Okay, but if we think of the moving parts that this HDD has, right? Because it's required to spin the platters, it actually uses more power than a solid state drive would. So, because a solid state drive uses less power than your standard hard disk drive, it just means a lower energy bill for laptops, right? So it increases your battery life. Then you're probably going, what is the consequence of all of this? Well, we find nowadays that your more modern laptops or your more modern computers run off solid state drives rather than hard disk drives. But not always the case, dependent on the cost. Okay, you need to understand that for all these pros that solid state drives have, it has to have some sort of con. And what would that be? So these solid state drives are so much more expensive, okay? Because they only have a few hundred gigabytes of storage. So a desktop computer with a solid state drive may also have hard disk drives as backup storage. Okay, these are just the type of things that we have to look at. Cool, so let's look at what we have next. So then we have our RAM, okay? It's a fast temporary form of storage. All data and instructions that is currently being executed is stored in the RAM. So me presenting this PowerPoint to you right now, this is memory. So it's running out my RAM, but it's volatile. So let's say, for an example, I'm working on your PowerPoint and I have not realized that the laptop's battery is going to die. Because of this thing called volatility, okay? Volatility just means that all the data is erased when your RAM is turned off. So when your computer is turned off. So storage is not volatile. That's what we spoke about earlier. but RAM is volatile because when we switch our computer off, we all know this, we are going to erase all the memory from our RAM. Perfect. Then we get something called processing devices. I know I am moving very quickly, but like I said, this is what you should already know. I'm just almost doing a refresher, okay? So processing devices retrieve the data from the RAM, okay? It performs sets of instructions. What is sets of instructions? That is your software. And it returns the processed data to the RAM. So there are two important processing devices in modern computers. This is a CPU and a GPU. But what is the difference between these two? So the CPU is responsible for processing general instructions. Every application makes use of the CPU to collect, decode, and execute instructions as they are required by this application or program that we're running. Where a graphics processing unit, so your GPU, this is responsible for the processing of instructions that create the picture on your screen. So what is one more vital for than the other? Well, if we think about our GPU, we need this for when we want to rely heavily on our online gaming, okay? Because it needs to physically create all those pictures on your screen the more you start to play. Okay, so let's check. So SSD is more, and also for video editing, 100%. Okay, the only thing with SSD that we sometimes need to remember is there is less space, less storage capacity. Okay, cool. Let's check what we're going to talk about next. So now we're going to talk about our output devices. So this returns the computer's instructions to the user. So these popular devices include, like we've said, our monitors, our screens, our printers, those type of things. Okay, perfect. So let's look at what we're going to talk about next. Next, we're going to talk about software. So there are two types of software that we are going to discuss. We're going to talk about system software and we're going to talk about application software. So let's check what is the actual difference then between these two things. Okay, so this is the difference between system software and application software. So system software is the specific type of software that manages the flow of data and information contained on the computer. So the most important type of system software would be your operating system. So when we think of system software, the first thing we must think of is operating system. Another type of system software is something like your utilities. Okay, so exactly like we've said here. So when we think of operating systems, we can think of Windows, we can think of Linux. I also make use of Mac, but that's just a personal preference, okay? But it can also be something like your iOS, your phone operating systems. Cool. Then we get something called application software. And this refers to any software that lets the user accomplish a function or create content. Cool. So this application software requires system software in order to function. So let's think about that. Would you be able to use an application software, let's say for an example like Word, if we didn't have some sort of operating system? Let's get a vote going here. Could I make use of Word if I didn't have Windows? No, I couldn't. Okay, so for every application software, there's some sort of reliable system software that it needs to use. So we always need to know that the operating system, that is why it is the most important type of system software. Perfect. But we then also need to remember that there are many different types of this application software that I'm talking about. So we get something called media players, we get spreadsheets, we get word processors. But if we look at some examples, okay? If we look at Microsoft Office, Google Chrome, Firefox, and Skype, those might all be online applications, or they might be applications that we can create shortcuts for, or we can download them as apps. Does it matter? No. Each one of those applications allow me as the user to accomplish some sort of task. Okay, let's think of this type of software that we're talking about, spreadsheets. So what would an example of a spreadsheet application software be? I'm going to ask that again. What is an example of a spreadsheet application software? Excel, 100%. Excel is an example of a spreadsheet application software because within Excel, it allows me to perform some sort of different task. Okay, but what else do we need to remember? These games and mobile applications, such as Spotify, Uber, they are also considered as application software. Okay, so basically the rule of thumb is this application allowing you to perform a specific task? If we think of an operating system, it performs many different types of tasks. It manages different flows. Whereas, so if we think of Windows versus Microsoft Office allows me to perform one task where Windows allows me to perform many. Okay, that's how we almost distinguish between the two. So now we're going to talk about the classification of computers. So we get a general purpose computer and we get a dedicated computer. So let's look at general purpose computers. So these compute a range of tasks, but lack super speed and efficiency. So the purpose of these general purpose computers, okay, is they differ from one another. Okay, so let's think of a laptop versus a desktop computer. Do they, in essence, necessarily differ from one another? Yes and no. If you think of a laptop versus a desktop computer, a laptop is mobile. I can take it with me from place to place. Whereas a desktop computer, yes, 100% you may be able to take it from place to place. It just might be a little bit more difficult. You might need to take a screen. You might need to take a box. Whereas with a laptop, it's all connected in one. But if we look at a laptop versus a tablet, can we agree it differs in many ways? In the sense that the processing power of a laptop is very different to the processing power of tablet. What a laptop allows me to do might be very different to what a tablet allows me to do. But if we think of very advanced tablets and maybe your cheaper or more your more cost-effective laptops, nowadays the technology is so modern and so up to date that a lot of these computers actually perform the same type of tasks, but we have lots of comparisons and characteristics that we have to consider when we look at these different types of general computers. Cool. So then we're going to look at specific purpose computers or dedicated computers. And these handle a specific problem or task. It uses a high level of accuracy and processing power. So examples of this would be a server or an embedded device. So supercomputers are extremely expensive, and the applications are specialized activities or tasks, such as weather forecasting. But if we think of this, if we have a server, okay, and this is maybe something that we're going to look at later on in the week, but servers run off different operating systems to what normal computers do, in case you didn't know. But in saying all of this for these specific purpose computers, okay, it might not always have a high processing power. Can you think of a specific purpose computer that you may have used every day when you were at school? Okay, this computer handles one specific problem or task. Okay, it's an example of a dedicated purpose, a dedicated computer. Can anyone think of what that could be? Ooh, we're getting your, oh, someone raised their hand. Can you guys chat in the, send me, okay, Wi-Fi router. Okay, almost. Yes and no in lots of specific ways. I'm looking for more of something that when you were in class or when you were, think smaller, think something you carried with you all the time, okay? But keep in mind, it may not have a high processing power. Okay, you guys are going to kick yourselves when I tell you what it is. Okay, think of something you used every day when you were at school, okay, and it only allows you to perform one specific task. You can't do anything other than those few specific things on it. Let's see if anyone, a calculator. This is amazing. Look at you go, guys. Think about it. A calculator is the most important, let's say, dedicated computer that we use every day. Can I send an SMS on it? I cannot. Can I phone on it? No. But I can calculate accurate mathematical calculations on it. Okay, so one that doesn't have a high processing power necessarily when we're talking about a calculator versus a computer, it might be, it's something like that, your calculator. Okay, another example of a dedicated computer in actual fact is something like your microwave or your washing machine. They don't necessarily have a high processing power, but they only perform one specific task. Okay, cool. So, okay, that lesson actually went a lot quicker than I thought. So let's just discuss the homework firstly. So as you can see, we use the, I've changed the textbook, but actually not really. Okay, we're using the theory textbook now. I will give you the link for the theory textbook if you don't have it, okay? But I use the textbook that was developed for the CAP syllabus. It's available on Siavula, and it's such a great textbook to make use of. So for homework, I want us to look at some multiple choice questions and true and false, okay? What about a camera, okay? So let's think of a camera for an example, okay? Would a camera be an input device or an output device? Number one. But 100% a camera is a dedicated computer. That is amazing, okay? Love that example. But would a camera be an input device or an output device? It's going to be an input device. Yeah, someone raised their hand. Let's go. Okay, why is it going to be an input device versus an output device? Anyone? Someone? Okay, so a camera is an input device because we're getting data and information from the camera. Okay, we aren't taking a picture and giving it to the camera. The camera is giving us the picture. Okay, does that make sense? Cool. So let's look at the homework questions that I want us to go over. So they're multiple choice, like I was saying, they're available. The questions is in the theory textbook. I'll send through the link now. But they're all very simple. It's all multiple choice, and I want us to go through it as like a class next week. Next lesson, sorry. So let's read here. So let's do number 3. So it says, which one of the following is not an output device? So if we have to think of A, B, C, and D, I have not necessarily gone through input devices specifically versus output devices, but would the answer be A, B, C, or D? Let's get some voting going over here. For number 3, which one of the following is not an output device? B. Okay, what other letters? Okay, we've got a second B. Let's go. Is everyone else confused? Okay, C. Ooh. Okay, now we've got some competition going. So we've got 2B, 1C. Okay, let's see. Okay, so we've got 3B and 1C. Okay, 4. Okay, let's check. Okay, so. Ooh, okay, look at that. Okay, so someone said here, well, if a monitor is touchscreen, then it could be D or B. Okay, but if we assume for the fact now that the monitor is purely just a monitor, okay, if we assume that it's purely just something that we are looking at, okay, the answer, look at you guys go, I'm so proud of you, the answer is B. Okay, let's think of how these things work. An output device. Now, if we think of a printer, I'm taking some sort of document, okay, and I am sending it some sort of information to get something out of it. So I'm sending it information and a piece of paper is being printed for me. So some output is happening. But let's think of a scanner for an example. A scanner might be an example of an input device because I'm taking some sort of piece of paper for an example and I'm scanning that in and I'm getting it back from that. Okay, it could be an input device. What type of output is happening with C? If we think of speakers, what output is happening with C? What is the output at C? Because we all know that the output at A for a printer would be your actual piece of paper being printed. Okay, sound, output, 100%, music. So we call it audio. Okay, audio is the output for speakers. So the output for a monitor would be the actual image, would be the actual picture that we are looking at on our screen. So the reason B, a keyboard, is an input device is because I am taking my keyboard and I'm physically typing click, 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 click on my keyboard, okay, to get some input into my device. Okay, I hope that makes sense to everyone. Cool. Then we look at 4 and 5. Okay, let's look at number 5. Which type of software is built for a specific purpose? System software, utilities, application software, or none of the above? Everyone should get this because I went through this for about half of our lesson today. Is it A, B, C, or D? We're looking at number 5 now. D, what type of software is built for a specific purpose, like playing a game? Look at you go. Everyone is getting this. This is amazing. 100% the question was a trick. Okay. And I'm so glad that you guys didn't fall into that trick. Okay. No one let you fall into the hole. You built a good grounding. Okay. So what type of software is built for a specific purpose? So some sort of application software, because system software allows me to perform many different tasks. Okay, cool. I'm so glad that we discussed that. I'm so glad that none of you fell into that trap. Awesome. So for number 6 of your homework, what you have to do is it says here, choose the answer and write true or false next to each of these. So for A, B, C, D, and E, you must tell me whether it's true or false. If it's false, I want you to correct that statement. Okay, so when you correct it, you have to change the one word. That's the problem. So let's look at answer B. Okay, let's do the first part of the question as an example. Is B true or is B false? Hardware refers to the set of instructions a computer uses to complete any task. Is B true or is it false? Ooh, look at you go, it's false. Okay, so we've got one false. Okay, so everyone is getting false. This is amazing. So what makes it true, guys? What word would I have to change hardware to make this statement true? Software. Look at you go. I'm so proud of you. This is amazing. Okay, software refers to the set of instructions a computer uses to complete any task. So that should give you a way on how we're going to answer this for the homework. Okay, cool. So let's look at number 7. So what number 7 wants you to do is, if the process is input, what would the description of that be? The description is, in the second step, the data is stored in the computer's temporary short-term storage called RAM. What would that be? Okay, so I'm not going to go through this one for now, okay, just because let's start finishing up. So that's your homework for me. Please look at number 1 to number 7. I'll go through that with you. Okay, so what have you actually learned today? Well, we've summarized the general model of a computer. We've spoken about hardware and software, and we've spoken about types of computers. And you are all nailing life at the moment. It's amazing. I'm so proud of you. What a great start to your week. Okay, so tomorrow I'm going to be talking about input devices specifically and output devices and different types of hardware. Okay, so I just want to send this link. Sorry, let's just send this link. Okay, I just want to send the link to the chat for you so that you can download the theory textbook. Okay, and that's the link for the theory textbook, so everyone can do their homework. Okay, thank you, grade 10. What an amazing lesson. Okay, hope everyone has an amazing afternoon.